Good day, everyone. My name is Janel Teana Fernandez, and in this video, we will be discussing three important topics: networking fundamentals, networking types and topologies, and network models. Now, this presentation is part of our course project for data communications and networking at AMA Online Education. Now, let us begin by exploring the basics of networking and then move on to different types and layouts of the networks, and finally understand the models, how the data communication happens. So, number one, networking fundamentals. So, networking fundamentals refers to the essential concepts or the basic components that allow computers and devices to connect and communicate effectively. And each of these devices on a network has a unique IP address, which acts like its own identity or the computer's identity. Protocols such as TCP/IP set the rules for how data is transferred. And on the other hand, subnet masks help organize networks by dividing IP address to its portion, network, and host portion. So understanding these basics are critical for managing any network that you're going to have. So the key concepts of networking. First is the IP address. Number two is the protocols. Number three is subnet masks. So IP address, it is a unique identifier assigned to each device on a network. So it is a unique number assigned to every devices, allowing it to be identified and communicate with other computers. Then next is the protocols. Protocols, these are rules that govern how data is transmitted and received over a network. It allows computers to set rules and standards that devices follow to exchange data reliability and securely. Then lastly, subnet masks. These are numbers that separate the IP address into the network portion and the host portion, helping organize and manage networks. So here we have the picture, and as you can see on the screen, this is where they divide each of these numbers. So IP addresses allow devices to be uniquely identified, and protocols ensure data is exchanged correctly and securely. This is the purpose and significance of the fundamentals of networking, so that networks can be organized and managed better together. These concepts make communication between devices possible and efficient. Number two is the network types and topology. So networks are classified by their size and range, such as LANs or local areas like offices, and WANs, which covers larger areas like the internet. The physical or logical layout of devices in a network called topology. So common topologies includes bus, where devices shares only a single connection, star, which centers around the hub, and ring, connected around a loop, and mesh, offering multiple paths for data. And the choice of network type and topology directly influence how efficiently data moves and how resilient the network is to failures. So here I'm going to show you first the network types. Here we have LAN or local area network, MAN or metropolitan area network, WAN or wide area network. So LAN, this is a network covering a smaller area like a home or office, offering higher speed connection. Then MAN, on the other hand, it covers city or campuses or larger than a LAN but smaller than WAN, because WAN is the widest area that can cover. This is a network that spans large geographic areas, connecting multiple LANs like the internet. So moving on to the types of network topologies. Here we have four types of topologies that we did in the last activity of uh, this core subject. So here we have bus topology, that all devices share a single communication line. It's simple, but it can slow down if many devices can communicate simultaneously. And the next is star topology. So this happens when devices connect to a central hub or switch, and it is reliable because if one device fails, others are unaffected. And then next is the ring topology. So ring topology, this happens when devices form a circular connection that pass data around the ring. So if one device fails, everything can disrupt the entire network. And lastly, the mesh topology, which happens when every device connects to multiple others, providing high redundancy and reliability, but it's more complex and it's more costly. So the purpose and the significance of these network types and topology is that it ensures efficient data flow, better performance, and easier management, and it helps the network meet its organizational needs, improves its reliability, and simplifies troubleshooting. So the last part is our network models. So what are network models? Network models provide a blueprint for how communication should occur between devices. So these models help design uh, protocols and troubleshoot networks by defining clear roles for each part of the communication process. So here we have two types of network models. The first one is the OSI model, or which we call Open System Interconnection. The second one is TCP/IP model, which consists of 4 layers. The first one has 7 layers. TCP/IP means Transmission Control Protocol or Internet Protocol model. So the OSI model is a 7-layer framework that explains how data move from one device to another in the networks, and each layer has a specific role, from sending electrical signals on the top physical layer, or on the bottom from the picture that I'm gonna present, to showing messages on your screen, or the application layer. And then the second model is the shorter version of the OSI model, which consists of 4 layers. The TCP/IP model is a 4-layer model used to guide how data is sent over the internet, and it's more simpler than that. And it is the actual model that is used in real world networking. Now I'm gonna explain the first model, which consists of 7 layers from physical to application. First part is the physical layer. Physical layer, this transmit raw bits over physical media like cables. Then the second one is the data link layer, which handles error detection and frames data for physical transmission. And then the third part is the network layer, the last part of hardware layer, is it routes data packets between devices across the networks. the heart of the OSI model, which is transport layer. This ensures the reliable data transfers and error recovery. Now moving on to the software layer of OSI model. Session layer manages sessions and connections between applications. Presentation layer, this translates data, formats, encryption, and compression. Lastly, application layer, this interfaces directly with users, application, and provide network services. For our second model, we have TCP/IP model, which consists of 4 layers, or what we call as transmission control protocol or internet protocol model. So first, we have the network interface layer. So this layer manages hardware and physical connection to the network. And then the second layer, which is the network or internet layer, it handles logical addressing and routing of data packets just the same way. And then transport layer, it provides reliable data transfer and error checking just the same way as the heart of OSI. And then application layer supports network application and protocols like HTTP, FTP, and SMTP. So what is the purpose and significance of these models? So these models provide a structured framework to enable effective communication and simplify troubleshooting across different network systems. So they help standardize how devices interact, ensuring compatibility and efficiency in data exchange. So that is all, and thank you so much for watching my video presentation. I hope this helped you understand the basics of how networks work and how different devices connect, how data flows through the system using models like OSI and TCP/IP. And once again, thank you for your time, and I hope you found this presentation informative and helpful.